The main system and the canonical equations of the displacement method is article number 3.15 of the book Mechanical Systems Calculations of the Marine Facilities. When deciding the main issue of statics, fighting of the support reactions and the drawing up of the mathematical equations of balance of the elemental mechanical systems, for statically definable systems, we can use two general approaches, the so-called force approach and the displacement approach. For the force approach, we have to draw up the equations of the compatibility of the informations. We say canonical equations of the force method. That is when we first have to do of the assigned system and the assigned statically indefinable system and determinable system. We have to do the main system. Main system the same as a statically indefinable assigned system, but with a cutout of the extra links unnecessary for the geometric invariability of the assigned system. And instead of the cutout extra links, we apply to the same point the reaction forces, efforts, maybe not only forces, but could be the moments of the reaction. After that, we can decide the the informations compatibility equations of force method, as which are the canonical equations of the force method. Decide, find the factors of these equations for the summands, and find we can find as well the free terms of the canonical equations. Next, decide these equations and find the forces due to the deformation of system, the forces action in the extra link which we did cut out when do the main system of the force method instead of the assigned system. Okay, so and for the displacements method, we have the another approach to determine what is the main system for the displacement method. First, we would please consider the mechanical system assigned shown on the figure 3.15.1 on the left, summing A. This is a 3 times statically indefinable mechanical system. System consists of 3 stands, 1, 2, 3, with other of the same material. So models of the elasticity is the same, and other transverse sections could be I1, I2, I3. This is moments of the inertia of the transverse section of the stands, and we have two beams. They connected here by the hinge. One beam of the transverse section of the same material. E modulus of elasticity is the same, but other sections could be I3 or here or the same. Horizontal beams are the same. Rigidity characteristics of the transverse section. And for this 3 times statically indefinable mechanicals, we will not go into the very complex explaining why it is 3 times. Is not so much complex, so everybody can do that, considering the system of each degree of the static indefinability. We can, as for the displacement method, we can consider together the number of the degree of the indefinability as a number of the angular indefinability, as how many the rigid nodes the system has. This we have 2, 1, and the second one the rigid nodes, and the second is the linear indefinability of this mechanical system, and we can consider to do that the hinged scheme instead of this one. So to replace all joints in the system, it is fixed joint or very rigid joint. This rigid joint, this is the hinged, this is embedded joint, etc. We can reduce all connections in the mechanical system by the hinges, and we can after that can consider how many displacements is possible, what is the degree of the freedom of the hinged scheme, which we consider instead of the assigned statically definable scheme. So we have here, if we replace all connections by the hinges, we can only one displacement, the horizontal displacement of the up horizontal two beams connected here in the hinge. To the it can move to the left or to the right, very for the instant small magnitude of the displacement. So we have together three displacement available and 3 degrees of the kinematic indefinability of the system. This is 2 angular displacements available here and in the rigid joint of the vertical stand left one and the horizontals, the beam, and the second is the angle of the rotation and the action of the external load of the second one, right one connection of the horizontal beam and stand the right one. And we have as well the common the linear displacement horizontal of two beams on the upper part of the assigned frame. So we have 3 times statically definable system. To do the main mechanical system for the displacement method, we not have to cut out the extra connections not required for the geometric unchangeability of system, but we have to put more connections. These connections are the extra connection like to control the horizontal motion of the point. So put here to the point, I don't know, the right one, up angle of the frame, we can put the horizontal connection, extra connection, to limit the displacement Z3 on the left, which is possible, on the right. And we probably under action of the external force F2 could be the motion to the left. And we have to add to the assigned mechanical system two floating embeddings which limit the bending motion, the element mechanical system of the connected in the nodes here. This rigid node of the mechanical system, this one rigid node, and we have to put in these two nodes the sliding embedding, not limiting the horizontal linear or vertical linear displacement of this node. So this one left on the right one, but which limits this the sliding embedding limit the rotation of the nodes, rotation zone. Okay, so this would be the system of the displacement method to determine the forces independence on the displacements in statically statical indefinable mechanical system. For the displacement method, we consider the kinematic indeterminability of the system, kinematic, due to we correspond this to the displacements of the mechanical system. Okay, what is the equations, canonical equations of the displacement method? The canonical equations, for the canonical equations, we consider the total of all forces, action, and the adopted extra connections, like as adopted the in the points of the possible displacement, adopted the sliding embeddings, and adopted the extra connections to limit the linear displacement of the nodes. So in this all extra connections, we just have to find the efforts. What is the efforts? Efforts in each of the extra connections, we indicate R, Y. It could not be only the force, it could be just the bending moment R, but just we are talking about the effort. So, and we assume the independence of action of all efforts on the mechanical system. That is superposition of action of all efforts to the displacement of the nodes of the mechanical system. So the total force in each definite one installed adopted for the mechanical system when doing the main system for the assigned one. Each extra force in the ice direction can be the first direction, second direction, could be third direction. It could be index I could be equal for the considered example to 1 or to 2 or to 3. It consists on the forces in each direction on behalf of the displacements in all other directions considered and on behalf of the external force. So the canonical equation is definition of the force action in the adopted new connections of the mechanical system when doing the main system of the assigned one as the equivalence this due to the concept of the superposition or independence of action of all forces in the elastic systems as a total of the force in the installed the extra embedding, for example, in this one corner, rigid corner, rotated for the angle z, on behalf of the force acting in the second direction, maybe, oh, excuse me, for the first one, we prove of ice, yeah, we consider that the first one direction is a rotation direction due to the bending of the right one up corner of the mechanical system. And to bend, to rotate this corner for definite angle as for the horizontal beam, the same as for the stand, the same angle of the rotation, we have to find the force action in this place. This force could be the rotating moment, the bending moment. R1 in this case for the rotation displacement is the moment, not the force itself. But it consists of the deducted to this definite one point under consideration all forces acting on the mechanical system. This is force due to caused by the displacement of the rotational displacement of the second left one up, not corner rotating for the angle indicated that the second acting on the first one. Plus the translational, the linear displacement of the all points of the upper one, two beams of the considered frame for the displacement linear Z2. So it could be the R1, R of the force of this displacement impacting the for the displacement after the displacement, the force rising in the point of right one corner of the main mechanical system which satisfies to the assigned system. So it will be the force R1, 3. So this means that this displacement causes as well the force in the first point, first corner of the considered mechanical system, etc. So we can have many displacement of the mechanical system, and each displacement will act onto the force in the direction of any one displacement. And besides, we have to consider the free sum. And free sum is the force acting in the each direction of each displacement of force, or maybe moment. Just this is more correctly to say the effort in the each one direction on behalf of the external load. Just for the considered example, the distributed load for two rods of the upper part of the mechanical system connected by the hinge here, and on behalf of the force, concentrated force applied leftward to the middle of the right one stand of the considered mechanical system. That is why we, in general, action of all forces, applied from the everywhere, deducted to the considered one point, we consider as an independent sum, and we say Ri in direction I for the first one, R first, etc. And the second index F mean that the cause of the action of the force is not the displacement in 1, 2, 3, etc. until n displacement directions. But the free sum not depends on the displacement, but free sum depends on the action forces on the in the direction of the displacement. Each one considered, we say I, maybe the first one, maybe another one. direction. So this is a canonical equation of the displacement method. And to decide these canonical equations, due to actually we do not have in the nodes the extra connections like the impedance, sliding impedance, or like extra connections to limit the linear displacement of any one nodes. It depends on the indeterminability, mechanical indeterminability of the system. As actually this is a theoretical concept, the availability of the listed the sliding impedance or the extra connections to protect to limit the linear displacement. So as this actually are not, so the force in this embedding have to be equal to 0 in the total. So the force, which is the result of the action of all displacements onto the displacement in the definite one direction, which together, according to the concept of the independence of action of all forces, gives us the definite force in the first of the extra connections we provide for the main system in accordance with the statistical or just mechanical, just kinematic indefinability of the assigned system. Plus the free sum like R1 F, F on the same force summoned on behalf of the action of the external load. For the second direction is the direction of the limit of the displacement in the point which corresponds to the degree of mechanical indefinability of mechanical system considered. For the second force, we have the same, because this extra connection actually absent in the for the assigned system and just only theoretical concept, so the force have to be equal to 0. So that is this means that all forces action in the this second extra connection assigned have to be equal to 0, and forces on behalf of the other forces action in this definite one summons on behalf of other forces action in the different definite one in this definite case second connection have to be equal to 0, etc. And in nth direction, the total of summons corresponding the displacements in each n directions of the limit, limit of the displacement, direction of the displacement limit by the assuming of the installing of the extra connections. It could be two types. First type is the sliding impedance, which limits the rotation or the angular rotation of the definite node of the mechanical system or other point mechanical system. And it could be extra connections limiting the linear displacement. In these all directions of these installed extra connections, theoretically, we assumed as a part of the concept of canonical equations of displacement method. The total of all forces acting, considering as well the forces under action of the external force, have to be equal to 0. As in the reality, we have no this extra connection. So this any nodes subject to be limited in the displacement are under action, not on the forces so applied to this definite one nodes, but on the forces applied to other elements of mechanical system and under the action of the external forces, which distributes in the mechanical system, and the definite one part acts in this definite one node. But this all have to be equal to 0 due to the we have no actually in the real state of the assigned the theoretical concept the extra connections limiting the displacements of the mechanical system and the method of displacements finding the forces and the other efforts in the statically indefinable mechanical systems. And after that, due to the concept of the elasticity, we can do mathematic transform, and each of the summand of the canonical equation can redefine as the, for example, the superstone summand as the factor R low case letter R with the indexes 1, 1. So this is the force which appears if the in the force direction and in the force direction of the limiting of the instead of the supports limited directions of the limiting of displacement of the node under the force acting in this definite one node under the action of the kinematic action of the displacement of this definite one node. So the displacement, unit displacement, not unit force, but unit displacement, caused the appearance of force. And the force, due to the concept of the elasticity of mechanical system, the force is proportional to the displacement. And the factor of the proportionality is the displacement of this connection. The displacement connection, we assume that is a displacement in the direction which in the connection limit the displacement and the action of unit displacement. This is theoretical. We have to understand that, and we keep talking about that. This, for example, is a factor, the displacement in the second extra support installed when doing the main system from the assigned statically indefinable system, and the force of unit. This is the force and action of unit force in the same second under the action of unit displacement, a kinematic action of unit displacement in the same one direction. And for example, here we have the second direction of the unit displacement applied, so in the second installed support, but this impacts on the force appeared in the direction of in the first one extra connection in the force direction. This is force direction is a direction of the force support in which the force support limits the displacement. So, and in this support, the force arises proportional to the displacement due to the linearity of the elastic properties of the material of the mechanical system. And from behalf of the kinematic impact of the displacement Z2 in the direction of the force support appears force, but this force appears in the direction in which the force support limits the displacement. The force support assumed as the part of the concept of the main system of the displacement method. And as well, assuming the free summand is the force R1. This is force in the direction which in the forced assigned support when doing the main mechanical system, in which this force support limits the displacement in the same direction of the displacement limit, but in the forced extra support, the force appears under the action of the external load. This is a free summand of the canonical equation. It has to be equal to 0 due to the in actual state for the assigned system we have now the extra supports, we have now the extra sliding impedance which limits rotation of the nodes, but do not limit the linear displacement nodes in two directions for the flight state. And as well, the main assigned system do not have the connections, extra connections, which limit the linear the linear displacement of each one nodes of the mechanical system. Decision of this system of canonical equation of displacement method gives us the unknown variables is the displacements of each node which we consider after decision of the after finding of the degree of static indefinability or kinematic indefinability for which likely for the displacement method. And in the points of the installation, the conceptual installation of the extra connections, we have the displacement due to the decision of the canonical equation system of equations under the assigned load assigned for the assigned system, not for the main system, but for the assigned system load. This acts and deforms the system, and we can decide this equation, so we can find the displacements. And after that, considering the dependence of displacement and forces, we can find the forces in the nodes of mechanical system or the assumed adaptation of the extra connections. So questions and comments. Attaching displacement to additional connections of the main system to eliminate differences in the deformations at the assigned statically indefinable mechanical system. So we have no differences in the deformation of the assigned statically indefinable mechanical system and the directions in which we found the connections, in which we found the connections, and to install the new one connections in accordance with the displacement method. And these displacements are just the conceptual indexes to determine the canonical equations of displacement method to find the displacements under action of the external load. 3.15.2 using the principle of superposition when finding the main displacement, that is the displacement of additional connections in which the individual states of the main system are considered, in each of which the external load act one of the main displacement occurs. The main displacement is the displacements in the directions of the assumed the extra connections we adopt when doing the main system of the displacements method of the assigned mechanical system. So when we consider the equations, the system of the equations of displacement method, we have to consider all forces acting in the installed and the adopted extra connections in the directions of the limitation of the displacement by these adopted connections extra. And these forces in these directions are the common impact of all forces acting in the assigned mechanical system. So this is the external forces, and this is the forces not the assigned mechanical system, but of the main mechanical system. This is the forces on behalf of the assigned external load, and the forces of the subject to find under the forces appeared under the kinematic impact of the displacement or displacements in each of the extra connections adopted when doing the main system of the statically indefinable mechanical system. So we consider the superposition. Superposition, that is all forces in the mechanical systems, assumed elastic mechanical systems, acts like independent, and we can find the resultant as a total of the independent action of all factors of external forces or internal forces of the mechanical system. So 3.15.3 physical meaning of the canonical equations of displacement method is the equality of reactions in the additional connections of the main system to zero is the equivalence to specified statically indefinable system and the basic one. As the assigned basic one system do not contains the extra connections installed to do the main system of the displacement method of the assigned system assigned basic system. That is the absence in the reality of the extra connections. Results that is the forces, which are the total of the forces acting on the nodes, the forces on behalf of the external loads, and in all other nodes in which we install the extra connection to limit the displacement, which corresponds to the kinematic indefinability of the mechanical system. These efforts caused by the kinematic impact of all the nodes in each directions we limited by the extra connections is to be equal to zero. This is a physical sense of the canonical equations. Equality to zero, the force of all factors impacting together common in each of nodes with extra connections assumed due to the concepts of the main system of the displacement method. 3.15.4 the system of canonical equations of the displacement method. The terms of canonical equations that depend on the main displacement correspond to the reactions in additional connections, and the terms of the equations that depend on the external law. Yeah, we have two classes of summands in the canonical equations. One class of summand is the groups of summands. The one is forces arising in each directions of all additional connections limiting the displacement of the mechanical system. These forces due to the elasticity arises, and these forces in each directions impacts the displacement in all directions of limited directions of the extra connections added, impact the force arising into each one of these considered directions due to the elasticity of the mechanical system, as well as the free summands independent on the displacements of the mechanical system nodes, in which we adopt the additional connections, the forces, as well defined on the action of the external load. So if we have many external loads, so we can consider the action of all the external loads. It could be distributed load, the concentrated force, distributed force, or maybe distributed moment or concentrated moment acting on the elements of mechanical system. This all action on the force in the direction of displacement of each adopted extra or additional connection, finding the main system of the assigned statically indefinable system. These all forces we can consider like the independent action. Thank you.